Okay, so today we're going to be talking about some special angles, and the special angles are the three that I've written here on the side of the paper. They are angles that have a radian measure of something with a 3 in the denominator, a 4 in the denominator, or a 6 in the denominator. Okay? And so you can keep in mind these special triangles here. Alright? These special triangles will help you solve, for example, sine of pi over 3. Alright? For example, we know that the sine of an angle, there's a little x here, is equal to the opposite over the hypotenuse. If I think of this special triangle and I want to do sine of pi over 3, it is the opposite side divided by the hypotenuse, and so it would be square root of 3 over 2 divided by 1, or just square root of 3 over 2. So we immediately know that the sine of pi over 3 is square root of 3 over 2. The sine of pi over 4 is square root of 2 over 2. And the sine of pi over 6 is 1/2. And so forth. Alright? So you get these special triangles sort of memorized in a little bit, and these 6 things. Alright? I've written them kind of strangely. Your sine and cosine, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. These are reciprocals of each other. And then this and this is a reciprocal. And then that and that is also a reciprocal. Notice that this is A over H, and this one is H over A. Yeah. Okay, so looking at a couple of examples, how do I find, for example, the sine of something a little bit bigger? 3 pi over 6. Actually, sorry, let me change this to a 5 pi over 6. Well, what I want to do is I want to draw out the angle of 5 pi over 6. So if I think of this here being a single pi, I need to break this into 6 equal pieces. There's 1, 2, 6 pi over 6 would be here, or a full pi. Okay, that for some reason people have trouble realizing that 6 pi over 6 is actually the same as just pi. And so the idea is that you want to go to 5 pi over 6. So how would you get to 5 pi over 6? Well, I would rotate around. I could, in theory, if I wanted to, rotate around to 6 pi over 6, and then back up 1/6 of a pi. Because if I'm at 6 pi over 6, and I back up 1/6 of a pi, then I'm at 5 pi over 6. This angle right here is 5 pi over 6. Now I can kind of complete this with the triangle, and this is a triangle with pi over 6 right there. And so if I look at my special triangles here, I realize that this triangle has pi over 6 in it. Now I'm going to take this triangle and I'm going to write it up there exactly as it's seen. Pi over 6. What's opposite of pi over 6? 1/2. What's below pi over 6? Square root of 3 over 2, and 1 is right there. So I'm going to write this like this, 1. square root of 3 over 2, and 1/2. Okay, and so the sine of an angle, since I'm asking for the sine, I always go with the opposite over the hypotenuse. So it's 1/2 over 1. And so the sine of 5 pi over 6 is 1/2. Okay? Now, what if I wanted to figure out the cosine of 5 pi over 6? I would do the same thing. I'm going to repeat it here just so that you can see. I want to go to 5 pi over 6. So what I want to do is I go to 6 pi over 6 and I back up 1/6 of a pi. Back up 1/6 of a pi. Then I write down my special triangles like that. This is 5 pi over 6. And so if I want the cosine, I know that the cosine is the adjacent over the hypotenuse, or square root of 3 over 2 divided by 1. Okay? And now the thing about this is this one is actually going to be negative. The end result will be negative. And the reason is because it's cosine is always negative in this quadrant. You've got something called the cast system. Sine, cosine, and tangent go like this. I believe it goes like this. C A S T. Cosine is always negative in this one. No, sorry. I believe I wrote it wrong. I think it's C-A-S-T. This is the first time I'm using this, so I'm kind of a little confused about it myself. So it's C-A-S and T. Okay? So what this means, these tell you which ones that are positive. Okay? And so cosine is positive here. The others are negative, tangent and sine. All of them are positive here. Sine is positive here, and tangent is positive there. So they're all positive in two locations. They're all positive here, and then they each have one more positive value. And what this actually means is, I'll explain the theory of it a little bit more in class, actually. But for now, I'd rather just skip it, and we'll continue on with another one of these. So let's go with tangent of 7 pi over 4. Okay, what happens if these start getting bigger? So what I want to do is I want to rotate around, keep rotating around. Let me get something a little more. Well, I'll rotate with the pen. I'll just draw it on here. If I rotate around this much, that's 4 pi over 4. Now if I rotate around this much again, that's 8 pi over 4. But I need to go to 7 pi over 4. And so what I want to do is I want to back up 1/4 of a pi. Okay, so now I know that this is a pi over 4 triangle. And so what I do is I go and I grab my pi over 4 thing here. And then I say, well, it's the square root of 2 over 2. Square root of 2 over 2. And a 1. And now, tangent is opposite over adjacent, or this divided by this. Square root of 2 over 2 divided by the square root of 2 over 2. And if I think of my cast thing, only cosine is negative here. And only cosine is positive here. And so, therefore, this actually must be negative. And so, in the end, it's a negative 1. Okay. Let's figure out another one here. Secant of let's go with 3. No, I already did a 3. No, I can do that. 3 pi over 4. So I draw my little box. I go to 4 pi over 4. I back up 1/4 of a pi. So I know that this is pi over 4. I'm doing secant of 3 pi over 4. So I go up to 4 pi, back up 1/4 of a pi, put my special triangle here, square root of 2 over 2, square root of 2 over 2. Then I go and I look at secant, and I say that secant is hypotenuse over adjacent. The secant is the hypotenuse, 1, divided by the adjacent, or square root of 2 over 2. 1 over the square root of 2 over 2 simplifies to 2 over the square root of 2. Should make sure you can get that algebra. Okay? And so there you have it. Now we have to decide if it's positive or if it's negative. Remember, they're all positive here. Signs are positive here. And since secant is associated with cosine, this must be negative. So these two are associated with each other. For example, when I'm talking about the CAST thing, when I'm talking about the CAST, this stands for cosine and secant as well. This is just all of them for sure. This one stands for sine and cosecant. And this one stands for tangent and cotangent. Okay? Because it also includes its reciprocal function. Alright, I'll do one more. Actually, let me skip to a new page and do something a little more complex. So, what we've got is, let's say we want to try and figure out a large thing here. Let's say we want to do cosine of 3 pi over 4 times the tangent of 7 pi over 6 divided by cosecant of pi over 2. Okay. Now I didn't talk about the two angles yet, so I'll talk about those this time. So basically what I need to do is I need to figure out all three of these things and do cosine of 3 pi over 2, tangent of 7 pi over 6, and cosecant of pi over 2. Figure out each of them separately. Then I'm going to take them and write them in. Whatever I get, I'm going to write them in, basically, these parentheses. So I'm going to figure out cosine of 3 pi over 4, and then write it here. Tangent of 7 pi over 6, write it here. Cosecant of pi over 2, and write it right there. So cosine of 3 pi over 4. I wrote that down wrong. If I go to 4 pi over 4, and then I back up 1, then I end up with the square root of 2 over 2, and the square root of 2 over 2, that's 1. Now the cosine is adjacent over hypotenuse, so it is equal to just the square root of 2 over 2 divided by 1. And so this is actually the square root of 2 over 2. Now we have to decide if it's positive or if it's negative. Remember that all are positive here and sine is positive here. So therefore cosine is probably negative, or is negative. Tangent of 7 pi over 6. I'll just do it the same exact way. I go to 6 pi over 6. Then I actually just have to go forward one more sixth of a pi for a 7 pi over 6. If this is 6, that would be 7. Now the pi over 6 triangle looks like this. 1/2, square root of 3 over 2, and 1. Okay, I'll zoom in on that a little bit. Square root of 3 over 2, 1/2, and 1. And I'm doing 7 pi over 6. And I'm doing tangent. Tangent is opposite over adjacent, or 1/2 divided by the square root of 3 over 2, and tangent is positive here, C-A-S-T. These two 2's cancel, and I'm left with 1 over the square root of 3. 1 over the square root of 3. Excuse me. Okay, and then I wrote the 1 over square root of 3 in my thing here for tangent of 7 pi over 6. Okay, now the last one. Cosecant of 1/2 pi, or pi over 2. If you go here and you end up at pi over 2, whoa, this is a little strange. You got to think, oh man, there's a problem here, because there is no triangle that we can use here. All right, and so for the cosecant of pi over 2, let me go back to cosecant. Cosecant is hypotenuse over opposite. In this case, you can think that h is equal to a y value. Sorry. O is equal to a y value, and A is equal to an x value, and h is always equal to 1. All right. So let me zoom in on that. You can kind of think of these three formulas right here. O is equal to the y value, A is equal to an x value, and H is equal to a 1 always. Okay? Now, what you've got is, when you get to a situation like this, you have to have the x and the y coordinates figured out. So it's 0 and 1 right here. And it is -1, 0. Here it's 0, -1. And here it is 1, 0. So if I'm figuring out cosecant is h over 1, or sorry, over opposite, but opposite is actually equal to a y, so it's h over y, and h is always 1, and then the y coordinate here is also 1, and so it is 1 over 1. You always look at the y coordinate if you want the opposite side, and you always look at the x coordinate if you want the adjacent side. Alright, and I'll explain the theory behind that again in the class. So it's a bit long. So then I just put 1 over 1, since the cosecant of 1/2 is, sorry, pi over 2 is 1. Now I take it and I put this stuff over here. So now what I've figured out basically is the cosine of 3 pi over 4 is that. Tangent of 7 pi over 6 is this. The cosecant of pi over 2 is that. And we're done, sort of. Now I just have to multiply this out and do a little bit of division. And so, I have a negative square root of 2 over 3, 2 square root of 3. Just multiplied the tops and the bottoms, and then it's divided by 1, so this is just cancels out. And so this ends up being a negative this is basically it, square root of 2 times 2 and the square root of 3. In the book you'll see that maybe that the denominators will be rationalized. I keep getting out of the camera here. And so what I can do is I can multiply this by the square root of 3 over square root of 3, and what it does is it rationalizes the denominator. That's what it's called, and this becomes 2 times square root of 3 times square root of 3 is just 3, so this actually becomes 6 over the square root of 6 with a negative. So it's negative square root of 6 over 6. So again, you just figure out each one and put them in there. And then once you've done that, you just treat them as if they're fractions. And you multiply or divide or add or whatever is required. Okay? So that is finding some special angles with trigonometric special angles.